So, in this video, we're going to look at how to identify the quadrant of an angle. Just give you an idea of what kind of question that might be, something like this, where they ask you to identify the quadrant or possible quadrants of an angle theta that satisfies the given conditions, like sine of an angle is positive, while cosine of that angle is negative. So what quadrant would that angle be in? So before we go into that, I want to make sure we're good with a little bit of background information. So generally what you'll have is you're going to have to work with these ratios, and then really how these ratios become standardized on a unit circle in terms of x, y, and r. Okay. So what happens then, of course, when you start out with a circle, right, regardless of how you rotate, how much you rotate, let's say you rotate into some angle in quadrant 2, then the terminal side of that angle is here. And remember to draw the reference angle and triangle, you always drop to the x-axis, right? So therefore, this is your reference right triangle, and your reference angle is right here between the terminal side of the angle and the x-axis, okay? So of course what that sets up is that relative to this angle theta, opposite is here, adjacent is here, and always across from the right angle is the hypotenuse. But because this is all standardized, and through that definition of dropping the perpendicular to the x-axis, what will always happen is the opposite will be the y-coordinate, the adjacent will be the x-coordinate, and the hypotenuse will be the radius of the circle. So really, when you're working with these definitions, then when they're asking these kind of questions, identifying the quadrant, we know that if you're talking about a quadrant, you already have a Cartesian xy plane, which means you're dealing with these definitions here, x, y, and r. Okay. Now, in that case, then let's take a look at a little bit more background information. Since you're dealing with x, y, and r, right, and we're talking about here, the radius is the hypotenuse. Really, you're looking at the Pythagorean theorem. You can say x squared plus y squared is r squared. So let's go ahead and define r. X squared plus y squared is r squared. So when I go to solve for r, I just have to take the square root of both sides, right? And what happens here is r is always positive. Now, why is r always positive? So let me go ahead and that. And normally I'll write this kind of thing, which is so much easier, right? Shorthand. But take a look. No matter what x is, it doesn't matter if x is positive or negative, once it gets squared, it's going to become a positive number. And the same thing is true with y. It'll always be a positive number. Now I'm adding two positive numbers, right? So I'll end up with a positive number. And then I take the square root of a positive number, which makes sure that that is positive. So r, the radius, is always positive. So when you're starting to work with these definitions and you're trying to find out what quadrant an angle is in, the radius is always positive. You can always assume that, okay? So now let's take a look at what this sets up. So if that's true, that the radius is always positive, and you look at these definitions, let's again draw the unit circle. Okay. And what we know is in this quadrant 1, right, x is always positive, y is always positive. In quadrant 2, x is negative, y is positive, right? So let's actually put that in here, x and y. In quadrant 3, x is negative, y is also negative, right? And then in quadrant 4, x is positive and y is negative, right? Put that again here. Now, what that does then, if you go back to your definitions and you say sine is y over r is always positive. So what gives this SIGN, its sign, is the y. So then you can say, well, sine is really the y-coordinate, cosine is the x-coordinate, tangent is y over x, and then you can deal with the reciprocals. So when you have sine of an angle is y over r, and again, you can really think of this as y over 1 if you're talking about a unit circle, right? And then cosine is x over r, but really x, right? Unit circle. So really what we have is x is cosine of the angle, y is cosine of the angle, is sine of the angle, sorry. Right. So in this case, in quadrant 1, cosine is always positive and sine is always positive. In quadrant 2, right, you can write it like this. The x-coordinate or the cosine of the angle is always negative. The y-coordinate or the sine of the angle is always positive, and so on and so forth, right? You can think of it this way, so you don't have to memorize it, hopefully. You'll just go back to your knowledge of the signs, S-I-G-N, of the quadrants, right? All right. So, for example, in quadrant 4, cosine of the angle is positive, sine of the angle is negative. Now, let's go ahead and look at some examples then. So let's say here, we'll look at example 1, and it says here, identify this quadrant, given this information, right, where's theta? So when you say sine of an angle is positive, remember sine of the angle is really, you can think of as y, because you can always use the unit circle to represent sine of an angle, right? You can sine it, well, I should say, I'm sorry, not, you can always think of the unit circle, right? If I have a bunch of concentric circles, for any particular angle, theta, I can drop perpendiculars to the x-axis, right? And it doesn't matter whether it's this radius or that radius or that radius. They all have the same sine of that angle, right? So we can use the unit circle to represent all trig functions if we want of that angle. So that's what I'm doing when I say sine of an angle is y over r, but really I can use the unit circle and say sine of an angle is just y divided by 1. So basically this opposite over this hypotenuse is going to be the same as this opposite over that hypotenuse is the same as that opposite over that hypotenuse. The ratios stay the same. Okay. All right, so now let's go back again to that example. So I know that y is positive, and here I know that x is negative, right? So in what quadrant do we have x is negative, right? X is negative and y is positive. Quadrant 2. That's the answer. Let's take a look at another example. And what I'm going to do here is pause the video and see if you can do the same thing I just did, basically go through and see if you can figure out what quadrant that is. Okay, so I'll continue then. Here we have the definition of tangent, right, is y over x. So we have, I know that y, the ratio of y over x is positive, right? But I also know that x, cosine of the angle, is negative. Okay. So if x is negative, then I know that that's this x right here. So I know that this ratio must be y divided by some negative number. This whole ratio ends up being positive. Well, the only way that can happen is if y is also negative, because then a negative divided by a negative is positive. So I know that y must also be negative. So now I know x is negative, y is negative. What quadrant are we in? We are negative, negative. We're in quadrant 3. Okay. Another example. Here, cosecant is positive, and cotangent is also positive of that angle. So now, again, pause the video, try this, see what you get. So here we have basically this definition is r over y is positive, right? Definitions again. And you should have these committed to memory, right? But I can really think of that as 1 over y if I'd like. But again, r is always positive. It doesn't really, not going to affect the SIGN of the number. So cotangent is x over y, right? And that's also positive. So what I know here then is r is always positive. So I have a positive number divided by y must be a positive ratio. So how is this going to be possible? Only if y is positive. So in this case, I know y is positive from this information. Now I can use this in here with the cotangent of the angle and say, well, okay, if I know that x, I don't know what x is yet, but y is positive, and I come out with a positive ratio, therefore x must also be what? Positive. So essentially I have x is positive, y is positive, right? I must be in quadrant 1. Okay. Now, this is a little bit of an extension, but it's sort of along the same lines, though. They're asking you to find all 6 trigonometric function values for each angle theta, rationalize when possible. So here they gave us the cotangent of an angle is negative 12 over 7. So already when I start out, remember cotangent is x over y. So I'm not sure if this negative is with the x or with the y. I really don't know yet until I get this information that theta is in quadrant 2. So I could represent this as visually as a right triangle in quadrant 2. So I would have some kind of rotation, then I go out to the circle, and then I drop my perpendicular to the x-axis. Here is my reference angle theta. So I know I'm in quadrant 2, so I actually do know now that x is negative and y is positive. So when I go to write cotangent of that angle is x over y, then I know that x over y is negative 12 over 7. I know the x is negative and the y is positive. So I can actually say here x is negative 12, y is positive 7. Sorry, I'm not sure that color's so good. So here, yep, y is positive 7, x is negative 12. So what I need to find to give you all 6 trigonometric values of that angle, I need to find the radius. So what is that going to be? Well, I use the Pythagorean theorem. X squared plus y squared is r squared. So I have negative 12 squared plus 7 squared is r squared. And now I can say, well, 144 plus 49 is r squared. So I have 193. And then now take the square root of both sides. R is square root of 193. 193 is prime, so that's all we can do with it. And now to go ahead and give you all the 6 trigonometric values, get a cleaner piece of paper, right? I would have here, now from this, I would have x is negative 12, this is what we're going to work with, negative 12, y is positive 7, and r is square root of 193. Right? So now we're just going to apply the definitions that we know, right? These here. And we'll have sine of that angle is y over r, which is 7 over square root 193. Now they want you to rationalize it, so you would multiply by square root 193 over square root 193 to get 7 square root 193 over 193. Cosine of that angle is x over r, so you'd have negative 12 over square root 193, which will end up being negative 12 square root 193 over 193. Tangent is y over x, so you have 7 over negative 12, but again, a lot of times you'll just write it this way, right? And then of course the reciprocals, so you have cosecant of theta, so that's just going to be this, well actually I'll just take that reciprocal there, 193 over 7. Secant theta, we'll flip that, square root 193 over 12, and make that negative. And finally, cotangent is, let's see here, negative 12 over 7, which is, I think, what we started with, right? Yeah, that's what we started with. All right, so there's an example where you had to know, use your quadrant information, right? And the last example we're going to go through is, again, something where you have to give all 6 trigonometric functions, and this is the information you're given. Cosecant of that angle is negative 4. Cosine of that angle is negative. All right, so what we have then is, we know the definition of cosecant is r over y is negative 4. So what we know is, since r is always positive, right, we don't know yet what y is, but the ratio is negative, so there's only one way that could happen, that is if what? Y is negative, right? And then over here, from this information, we have that x is negative, right? So already we know what quadrant we're in. Both x and y are negative, so we are in quadrant 3, right? So what we can do is go ahead and draw a reference right triangle to represent that. So let's say I'm here. I, rotate out quadrant 3, right? Then I drop to the x-axis, and here's my reference angle, right, between the terminal side and the x-axis. And now we have the quadrant we're in. What we have that we can work with is that r over y is -4. That's really -4 over 1. You can always put a whole number over 1 to make it a ratio, right? Well, we know the negative can't be with the r, it must be with a y, so I can really say r over y is 4 over -1. So that means here I have r is 4, I'm on a circle of radius 4, and then y is -1, and I need to find x. So I could say here, remember Pythagorean theorem, x squared plus y squared is r squared, right? And now just start filling in what we know. -1 squared for y squared, and then r squared would be 4 squared. So here we have x squared plus 1 equals 16, so x squared equals 15. And now when I take the square root, technically I get the absolute value of x, so I have square root 15. And now we get x is positive or negative square root 15, but I know I'm in quadrant 3, so I know that what? X is negative square root 15. Right? So here's the negative square root 15. And now we can finally get all 6 trigonometric functions at angle. So let me just write down what x and y and r are here. X is negative square root 15. Y is -1. And then r was 4, right? So now we go through and just say, okay, sine of that angle is y over r, which is -1 over 4. Cosine of that angle, x over r. X is negative square root 15 over r4. Tangent, y over x. So -1 over negative square root 15, which rationalized is going to be square root 15 over 15, right? And it'll become positive. And so now we can just do the reciprocals. Cosecant is -4, right? 4 over 1. Secant is going to be 4 over square root 15, and it's going to be negative. So we're going to have, but you're going to have to rationalize it. 4 over square root of 15, right? And then you're going to have 15 like that, right? And then finally, cotangent. Where were we? Here. So we're going to have square root of 15, right? When you flip this. Okay, so I think that covers it. Thank you so much for listening.